For lesson 7.1, we're really going to be getting into evaluating inverse trig functions. And for a trig function, that's what we've been working with so much in this past chapter. What goes in, what's part of our domain, would be an angle. What would come out would be a value. For example, you might have the sine of pi over 6 very clearly. What's coming into sine is an angle, perhaps in radians, perhaps in degrees. What comes out is some value, perhaps such as 1/2. What we're going to do for an inverse function is always switch x and y, switch the inputs and outputs. So what's going in, of course, will be values. And what's going to come out then will be an angle. So we're just reversing this. And really, today we're just going to be looking at inverse functions of inverse sine, cosine, and tangent. For inverse sine, I'm going to draw a little circle because this visual cue can help us out. The outputs that you're going to see for inverse sine will always be between negative pi over 2 and positive pi over 2 in radians. So from a fourth quadrant into a first quadrant. Just why those angle boundaries hold, we can talk about at a later time. But for at this moment, just realize that we're between negative pi over 2 and positive pi over 2. For inverse cosine, if we had an inverse trig function, any value coming in would just have one angle as an output, one input, one output. So we're going to actually come to an agreement that we're always going to have an output between 0 and pi radians. For inverse tangent, what we're going to see is the outputs look amazingly close to those of inverse sine. However, these endpoints on these boundaries will not be included. We will be between negative pi over 2 and positive pi over 2, not including pi over 2 or negative pi over 2 themselves. And with no further ado, we can actually begin to evaluate some of these inverse trig functions. So if you were asked to find inverse sine of negative root 2 over 2, we of course would know that we're going to be between negative pi over 2 and positive pi over 2. We'll only have angles that fit these boundaries. In the first quadrant, all trig functions are positive. Of course, we have a negative value, and that would require us to have our angle in this fourth quadrant. Hopefully you know your unit circle well, and you'd know that a reference angle for sine that would yield root 2 over 2 would be pi over 4. So we, of course, are going to have a reference angle of pi over 4, but between negative pi over 2 and 0, that output then would be negative pi over 4. Notice that if we chose positive pi over 4, that would be incorrect because the value for sine would be a positive root 2 over 2 in that first quadrant. For example 2, as we look at inverse cosine and see a negative value, once again we know that our angle must be between 0 and pi. That being said, we know that with a negative value, we won't be in the first quadrant. We're actually going to have to be in the second quadrant. Now again, what I hope we're very familiar with is that going back to last chapter, the cosine of pi over 6 was radical 3 over 2. So a reference angle of pi over 6 will have cosine having a value of root 3 over 2. Well, of course, in this second quadrant, a reference angle of pi over 6 would yield 5 pi over 6. And that's what our final answer will be. By way of comparison, going to number 3, inverse tangent. Well, again, just as we've noticed up above, we're going to have angles between negative pi over 2 and positive pi over 2. And again, in our first quadrant, all values are going to be positive, and yet we're going to look here and see that we need a negative value. meaning once again we're in the fourth quadrant. Now, hopefully you know that tangent, of course, is sine over cosine. And to be able to arrive at a tangent value of radical 3, sine would have to be root 3 over 2, and cosine would have to be 1/2. The reference angle that will allow that to happen is going to be pi over 3. So, we will need a negative pi over 3 angle to have a tangent value of negative root 3. So some of these problems we can do rather quickly and directly. Some problems are also going to be simply using a calculator. Unless you're told otherwise, given directions to work in a certain mode, you're going to always be in radians unless told otherwise. So quickly now we can double check our mode, and we are on the radian mode. To get to inverse sine, we'll hit second sine, and we can just type in negative 1/4, and very quickly come up with about negative 0.2526. You can see we need to go to the nearest thousandth, so that would be negative 0.253. I can't stress enough that what this is really an angle measure. Even though we don't see a pi here, we could even write a little r up in this top right corner. That's not required, but it's a notation for the radians. You're saying this is an angle. In a very similar way, we can say inverse cosine of 0.4, second cosine of 0.4. Again, we will get an angle in radians, and we'd get about 1.59. So 1.159. Again, you don't need the little r up there. Inverse tangent of negative 1.1. We can do that very quickly as well. And we'd get about negative 0.833. All of these are radian measurements. All of these are representing angles. But now look, we're of course going to look at some problems without a calculator. And that's something that we need to do more and more of. Sometimes students look at these compositions of an inverse sine of a sine, and the initial thought might be, oh, they simply cancel each other out. Whatever is inside will be our answer. For example, you might look at that and think, oh, we're going to get pi over 8. Well, look, even though we don't have a calculator, pi over 8, I hope we could all agree, is going to be somewhere in the first quadrant. So here'd be a pi over 8 angle. And we don't know what the y-coordinate would be on the unit circle. But regardless of whatever value we have, when we take the inverse sine of that, the inverse sine, remember, is always going to give us an angle between pi over 2 and negative pi over 2 here. And suffice it to say, as we're looking, pi over 8 fits that description quite well. Pi over 8 would be a smaller fraction, so pi over 8 it will be. It's a first quadrant angle. Inverse sine gives angles in the first quadrant. So at first glance, you might look at this and think, well, wow, yeah, inverse sine and sine just touch and they cancel. However, if we look at 5 pi over 8, 5 pi over 8 is a little bit bigger than 4 pi over 8. 4 pi over 8, by the way, is just pi over 2. So 5 pi over 8 is actually an angle in the second quadrant. It's right over here. Now remember that inverse sine will give angles only between negative pi over 2 and positive pi over 2, either in the fourth quadrant or in the first quadrant. Inverse sine will not get you an answer of 5 pi over 8. Instead, look for this reference angle. Pi, of course, is 8/8, and our reference angle would be 3 pi over 8. So suffice it to say, what we're really looking for is an angle where we know sine's going to have a positive value. It can't be in this fourth quadrant. That's where sine would be having negative values. In the second quadrant, we know sine gives positive values. So we need a first quadrant angle. The reference angle is the key. We will get an answer of 3 pi over 8. Taking a look at number 9, notice that the order has changed. We always start from the beginning, and inverse sine of 0.8 is essentially saying with this positive value of 0.8, this is a value inside, find an angle for inverse sine. Now again, the boundaries for inverse sine very clearly are between negative pi over 2 and positive pi over 2. And with a positive value, there will be some angle in the first quadrant. We don't know what that angle is off the top of our heads. But suffice it to say the y-coordinate on the unit circle would be 0.8. That's the sine value. So really what we're going to do then is take the sine of this angle. I could call this angle A. You're really saying, what is the sine of angle A? Well, it's now going to have an output of a value, but we know what that value is. The value would be 0.8. So here we have it, the first 3 problems. We can scroll down here and very quickly compare with example 10. Example 10, of course, just looking at pi over 12, of course this is an angle, that pi over 12, and it's a very small fraction. Pi over 12, of course, is some angle in the first quadrant. I don't know what my value is for cosine at pi over 12. It's deliberately chosen so that without a calculator we wouldn't know that. We wouldn't know the x-coordinate on the unit circle, in other words. But inverse cosine, if we looked at the angle boundaries for inverse cosine always go between 0 and pi. And at this point, you need to realize your final answer, as we're taking the inverse cosine of something, will be an angle. You have a positive value because the cosine of pi over 12 is essentially working out a value in the first quadrant. So we need an angle in this first quadrant, and it's simply going to be pi over 12. Taking a look at a very similar problem, 13 pi over 12. 13 pi over 12 is an angle that's going to go into the third quadrant. 13 pi over 12 is a little bit bigger than 1 pi, which is 12 twelfths. And we already know that inverse cosine only gives angles between 0 and pi in the first and in the second quadrant. You won't be able to have an answer of 13 pi over 12. So what we have to be careful about is how to get this proper angle. Obviously, we're going to wind up with a negative value. I don't know what that value is. We haven't memorized what the cosine of pi over 12 is. But in the third quadrant, with all students take calculus, only tangent is positive. The cosine of a third quadrant angle is a negative value. So working backwards, if we were to say, well, what angle will we get as we take the inverse cosine here? We know we have to go between 0 and pi. So we're going to be in the second quadrant. We need to find a reference angle to help us. And the reference angle is going to be pi over 12. If we were to make an adjustment and say that we are pi over 12 short from 12 pi over 12, we'd be at 11 pi over 12. And there we have it. Wrapping up, just want to point out that what goes inside inverse cosine is a value of pi. Now, cosine can never be larger than 1. So really you're saying find an angle so that the cosine's value is pi. Immediately we know we're in trouble. this is undefined. There